So in the previous discussions, we have discussed yung design process, um, in which na-discuss natin yung 6 steps, okay, in order to be able to come up with analysis and design of your system, okay. So, nandun tayo sa part na nandun tayo sa part ng nandun na tayo sa schematic, okay. So we are in the part na meron na tayong schematic. Okay. So, in this yung next step na involved in such process would be to develop mathematical models for schematic of physical systems. So, after nyo makapag-develop nung schematic, okay, we need to have a mathematical model. Okay. Now, we will be presenting two methods. Number one is yung transfer function. Okay. And number two is the state equation. Okay. It should be noted na ang transfer function nyo is basically in the frequency domain. At yung state equations nyo is basically modeling in time domain. Okay. Although as I pointed out dun sa ating as I pointed out before na we will be presenting yung state equations as an optional topic. Okay. So, dahil mas mag-concentrate tayo, mas magpo-focus tayo um, sa transfer function. Okay? So, it should be remembered na either gumamit tayo ng transfer function or ng state equations. We always start with applying, okay, the fundamental physical laws of science and engineering that is applicable dun sa system na ina-analyze natin. Okay. So, kung electrical networks yung pinag-uusapan, when we discuss electrical networks, okay, we use Ohm's law and Kirchhoff's law. Okay. For mechanical systems, okay, gumagamit tayo ng Newton's law of motion. Okay. So, that would be the first step. Kasama rin dyan yung paggawa ng mga assumptions so that your system would be in the end a linear system. Okay. And some other simplifications. Okay. Some other assumptions that would simplify, okay, our analysis but not oversimplify it. Okay. So, yan. Kapag nagmo-model tayo, isa din sa isipin natin is that may mga assumptions tayong kailangan gawin in which your system may be simplified. Okay. Yung model may be simplified pero not over-simplified. Okay. Now, for a dynamic system, batandaan natin na for a dynamic system, for us to be able to relate the input and the output, okay, differential equation ang description ng system nila or ng model nila. Okay. So, para ma-relate natin yung input dun sa output. Okay. For a dynamic system, ang lalaglagan niya ng equation or lalaglagan niya ng mathematical model is basically a differential equation. Now, the form of the differential equation, okay, and its coefficients are a formulation or description of the system. So, basically, kung yung system mo ang mag-determine kung ano ang order ng equation mo at yung coefficients niya, okay, nakadepende rin doon sa mismong system mo. Okay. And we take note that although the differential equation, okay, relates the system to its input output, it is not a satisfying representation. Okay, it is not a satisfying representation from a system perspective. Okay, so it is much preferred that a mathematical representation such as shown here, okay, in 2.1, where the input, output, and the system are distinct and separate parts. Okay, so makikita natin dito sa figure 2.1 na dito, meron tayong input, okay, meron tayong so yung input natin is input natin is R of t. Okay, tapos yung output natin is C of t. The thing is, kapag ito naka-describe ng differential equation as you would be able to see later on, hindi natin siya masiseparate. Okay? Dahil if we describe this system through a differential equation, yung magiging magiging resulting model natin is a linear differential equation, okay, of n order. So pagka ganun, medyo mahirap i-solve yung mga ganun type ng equation. Okay, so what we want to do or what we want to have is a model that can separate RP, CP, and the system. Okay, so ayan, yun yung objective ng modeling natin. Okay, also a representation where several interconnected subsystems, okay, like this one. So yung meron naman tayong systems like this one na marami siyang meron siyang cascade interconnection. Okay. Kung i-separate kasi natin itong RP tsaka yung output dito tsaka itong description ng system na to, okay, mas madali natin simplify ito kesa naka-describe ito as a differential equation. Okay, so in that case, that mathematical function or that mathematical model na hinahanap natin, okay, would be expressed in terms of what we call the transfer function. Okay, so that transfer function, okay, is what we will use to represent the system. Okay, so note that in figure 2.1, R of t, R of t represents the reference input, okay, while C of t represents the control variable. So basically, yung control variable nyo, yun yung output. Tapos yung reference input nyo, yun yung input. Okay, so a major advantage of frequency domain modeling is that they rapidly provide stability and transient response information. Okay, so meron siyang ino-offer na intuition. So importante yun kasi once na makita nyo yung model, marami na kayong calculations na or marami na kayong conclusions na pwedeng ibigay dun sa system niyo. Okay, so intuitive siya. Okay. It is also possible that we can see immediately the effects of varying system parameters until an acceptable design is met. So, pwede natin din laruin yung mga parameters ng system so that we will see kung ano yung epekto niya. Okay. So, yun yung isang advantage niya. The primary disadvantage of this approach, however, okay, is its limited applicability. So, time and again, sinasabi ko na kapag ginamit natin yung transfer function, ang pag-a-apply lang na ang mga systems that it can only be applied are those that are linear and time invariant, or those that can be approximated as such. Okay. Ang isa pang pwede lang natin pag-applyan ng ganitong system is yung tinatawag natin single input, single output system. Okay. So, single input, single output system. So, yun yung mga isa pa pwede natin pag-applyan. Okay. Now, with an increasing design scope, okay, the modern or time domain approach of modeling system is devised. So, kung medyo mas nagiging complex na yung system natin, mas ginagamit natin yung time domain approach or yung mas tinatawag na modern approach. Okay. The state space approach is a unified method for modeling, analyzing, and designing a wide range of systems. Okay. It can model nonlinear systems and systems with non-zero initial conditions. So isa pa pala natin tatandaan about the transfer function approach is that i-apply din natin ang isang assumption na gagamitin natin is that you would have zero initial conditions. Okay. So kasi kapag may initial conditions ang system niyo, okay, ang tendency is nagdadagdag siya as an input. So yung problem natin malalaglag sa isang multiple input na siya. Magkakaroon siya ng multiple inputs. Okay. So pero kapag yung state space approach can handle nonlinear system, okay, and systems with non-zero initial conditions. Okay. Time-varying systems and systems with multiple inputs and multiple outputs can be compactly represented in state space model, which is similar to the form of single input, single output system. So, ayun. The time domain approach can also be used for the same class of systems modeled by classical approach. Okay. This alternate model can give the control systems designer another perspective from which to create the design. Okay. The main drawback of the time domain approach is its lack of intuition compared to the classical approach. Okay. Isa pa, yung mga tools na kailangan natin para magawa or para gamit ng maayos yung time domain approach could also be medyo complex din. Okay. It requires the use of the tools of linear algebra since sa time domain approach you would be dealing with systems of differential equations. Okay. A few calculations must be made before the physical interpretation of the model becomes apparent. Okay. So, sa next topic natin, we will study yung Laplacian sword wherein yun yung gagamitin natin to develop transfer function models.